The way I thought about this was to have A, B, and C. None of them are square numbers, but when I times them together, I need to get a square number. So I want to make them as small as possible as well. So why don't I try and let A equal 2? That seems to be a good shout. Then for me to get AB as a square number, I'm going to have a multiple of 2 with B, and then maybe I times by the smallest square number that's not 1. Okay, I can't make it 2 as well. The smallest square number is 1, or I suppose you could argue 0. But anyway, the next square number up from 1 is actually 4, so I can times by 2 squared. So now I'm definitely going to get AB as a square number. C, I'm then going to also need to have it as a multiple of 2. I can't use the same square number there, so I try the next square number up. And this is definitely going to work. A is equal to 2, B is equal to 8, and C is equal to 18. When I times them together, clearly I get 16, I get 36, and over here, I'm going to get 144. So ABC, AB, AC, and BC are square numbers. Now, there's no way I can make this any smaller. I'm pretty convinced by that. If we add these up, we're going to get 28. We can't get 14. We'd have to halve each of them essentially, 1, 4, and 9, and actually they're all square numbers then. You can see that 14 is not going to work. So when I did it, okay, I messed around with it a lot more. I didn't get the answer straight away, but ultimately this is the way that I think is good to think about it, and gives the answer 28. There is a solution on the UKMT solutions page, which talks about it in a lot more detail and complexity. So you can follow that, but I quite like this way that I've explained it here.